Thank you. Is it okay if I start with a quick story that happened to me and my wife Monday this week? So we came to Barcelona last year for the first time to Ricard's DevOps Barcelona conference from our team from New York, many of which are here with us today and also presenting with us. And we loved Barcelona, so we were looking forward to come back here this year. Ricard invited us to speak, which we're very excited to be speaking with you on artificial intelligence and how we use it at our DevOps and SecOps practices at Amplify, our company in Brooklyn. So this year I came early with my wife to try to learn a different part of Spain. So we went to Seville, where we were there for a few days before we come to Barcelona. And my Spanish is not good, no bueno. We're working to improve it, but it's not good now. So in lunch on Monday in the restaurant, we couldn't read the menu. So we had a translator app, which wasn't working so well. It didn't understand the words in the menu. And so we could order wine, so we were drinking wine while we were trying to make the app understand the menu, and that wasn't working, and as we drank more wine, the use of the app was becoming even worse than when we started, so we really didn't know what to have for lunch. People behind us were from Oregon, United States. We didn't notice them. They were traveling also in Seville, and she said, "Would you like us to help you?" And we said, "Yes, we would." "Do you understand Spanish?" And she said, "No." And I said, then how can you help us? She goes, "They have a menu that's in English." And she gave it to us. So the thought occurred to me, and what we're speaking to you about today is this translation. She handed us this menu. It really solved all the problems for us, and we were able to eat lunch and continue to drink wine in Seville and make it here to Barcelona. We want to do the same. We want to hand you a menu that helps translate some of the artificial intelligence concepts into something that you can really go back to your companies and use. So that's why we came today. We traveled from New York. We're really excited to be here. I'll introduce my co-presenters momentarily. I have a few minutes of introduction, and then Alex and Jonathan will be presenting more of the technical material that we really hope you can take back and use after the conference is over. How was that story? No good? It's true. It happened Monday. This is what we want to do. We want to translate, as I mentioned, hand you a menu, the way those people from Oregon did to us, and make something real that you can use. We also noticed that part of our team is from the InfoSec group at Amplify, and information security extremely important, and there are some really important things to keep in mind when you're using artificial intelligence tools with confidential data for your companies. So we'll cover that and ask you to play safe. And then I think we have time for questions. We timed the presentation, but if we don't, we'll stay here at the break. Or please, if you like, email to us. And if you want to do anything more detailed than what we covered today, or if we can help in any way, we'll set a session with you if you'd like. And we can give you copies of our presentation, which has links to many of the things that we will be talking about today. Thanks, John. Go ahead. Yeah. We're going to cover some examples. So we look at artificial intelligence in two different flavors, predictive and generative. Alex and I will cover the predictive aspects of artificial intelligence on those three areas in how we do our engineering help desk, how we do severity 1 incident avoidance, and how we are looking to scale our databases to be more efficient in our use of Amazon Web Services that is in our back end. Jonathan will be presenting on capture the flag exercises supported by AI, and tabletop exercises also supported by AI. Thanks. This is the team, so please allow me to introduce Director of Development Operations, Alex Oskotsky, will be presenting after I'm done. Thank you. Johnathan Constance, Director of Security Operations at Amplify. Thank you. Carrie is in charge of our Information Security Committee. She could not be with us here in Barcelona. She's back in New York, but she's an important part of the team. And may I say that on all of our teams, on all of our three teams, many of our members are here. Some are in Ukraine, some are back in the United States. And the reason we asked Ricard if we could present together as a team is because that's how we work. We work as a team, and we thought that's how we should present to you as well. So we couldn't do any of the things we're describing today without all of our team members working together with us to get the work done that we need to do. A couple of things about the company that we just want to highlight. As I mentioned, we're headquartered in Brooklyn, but the team is remote first, so it's all over the world in many cases. Backend is in Amazon Web Services, so Alex will be presenting on DynamoDB and methodologies to scale that database correctly using AI support as well. We're mostly a software engineering team, so we follow agile methodology. And automation is really important. We operate a small team, and we try to be efficient as we can. A lot of the AI reality is that it helps us be more efficient. So there's AI hype, and there's AI, articles and blogs, but we try to get it down to what can we really use in our practices at work to be more efficient as a team. And that's what we're going to be covering today. The two flavors of AI that we're presenting are generative and predictive. You probably know these terms, so I just put them up there and make sure that it's clear that the generative AI, again, many of which Jonathan will be presenting, is to create new content from prompts that you give to language models. The ones that Alex and I are talking about are predictive AI, to find patterns in data that you already have and you want to do analytics on. And some examples of what we'll cover and some of the tools we'll be covering. And the next slide, some predicates, some things to watch out for. As I mentioned, next slide, John, if you would. Yeah, so if you're going to put your data into language models, you really need to understand the privacy of those models and your company's policies about the handling of your confidential data. So there's a great deal of caution to exercise here before you give that data into a language model. You don't know if the model is going to keep it, retain it, for how long, give it back to people that may not be entitled to have that information. So that's an important aspect of it. John's going to cover some ways that we've dealt with that. On the other side of predictive AI, what Alex is doing, the caveat is the data has to be structured. This is a lot of times a bigger lift than actually using the AI tools. You have to get the data into structured format, and I'll show you some examples of what we did to structure the data so we could use predictive AI tools in that data set. We use Slack at Amplify, and we have a Slack channel. Our name of our team is AstroTools. We support about 500 engineers around the world, and the questions that they have for us come in that Slack channel to a large degree, right? So the question we wanted to ask was, can we derive some predictive business intelligence from that data? So we took about a year's worth of Slack data, which is not that easy to get. You have to export the entire Slack domain, so you get everything that's in Slack, which for many of your cases may be a large data set. Then pull the channels out that you want. In our case, the channel's called AstroTools. And then you have basically raw JSON. So we used JQ to filter that data so we get the top level. In Slack, the top level is usually the question that comes in from engineering, right? So the question comes in, that's the data we wanted to capture. In that thread of Slack, it also gives you metadata about the original question. How many replies, how many people replied, which gives us some kind of idea of how complicated the question was and how difficult it was to answer the question. So we took this data, we got it into a CSV, and we uploaded it into this tool, ICO, which is a tool that's designed to do AI analytics on spreadsheet-style data, CSV data, Google Sheet, Excel, et cetera. And we start asking some questions to the data. So this is our data, right? We didn't put in a language model. This is our data that we're looking at for predictive purposes. And then we're looking to try to understand at the output side there, as I mentioned, we're trying to be practical about what we do with AI. We want some answers. Do we need to do better user training? Are people asking the same type of questions over and over again that we may be able to automate answers for them in a frequently asked question format? And do we have times where the help desk is busier than others, and we need to staff differently for that help desk? So if you go to the next slide, thanks, Tom. This is the tool. So it has, in this case, about a year's worth of Slack data. About 1,200 messages were in there at the top level, not counting the replies and the threads. And we ask questions over here. What's the most common user that's in there? What are the most common times? What's the average reply count? In other words, how complicated was it to answer the question? And the tool will take your question, sort of like ChatGPT, except it's operating just on your data, and start to give you answers. As you can see, I got some wrong answers. The main user was other, which doesn't help me because Slack produces messages that are not from real users, so that wasn't that helpful. So we have to clean the data up again or ask questions differently of the tool and try to find the answers that we have. So if you use Slack or any type of support mechanism and you can get your data filtered into a CSV format, you can use this type of tool to start to develop business intelligence. Could you do this with a query language, SQL? Maybe, but it's a lot harder. This was pretty powerful and very simple, and we start to get decent answers very quickly. The data for our incident response is already structured natively. We use a database, called QuickBase, Software as a Service database. That's structured data. So we were able to use a tool that comes with QuickBase, which is now in beta. So there's some work to do. It's early in the process, but we can ask questions about our data. So we had about 3 years worth of incident data in our database, and we could start to ask questions like, what is the product that produces most Sev1s? What are the teams that are involved? What are the times of day, the times of week, the times of month? And we start to analyze that data. And those are the outputs we're looking to have. Should we work with a team to improve the QA process? Did we do something wrong when we configured their environment? Should we go back and look at what we did there on the DevOps side, et cetera? And we really want practical output from that data. And on the next page is an example of this. So this, in the database, you tell it what fields of the database you think predict severity 1 outages, in our case, and then it starts its analytics, it builds a model, and on the next page, it gives you some time, some people, some products, and then we have to take this data and go deeper. Why is this team, why is this product, did we do something wrong, can we help them, did we misconfigure? Those are the questions we start to ask ourselves with the ultimate purpose of finding ways to avoid severity 1 incidents going forward. So that's an incident avoidance model. So those are 2 examples. The first slide said, we want to give you real solutions that you could go back and use. We want to get rid of the hype. You know, it's not Terminator. It's not ChatGPT writing a novel for you or doing your homework. These are examples that we can really use, so we hope those 2 give you an example. But going forward, Alex and John have taken it to a whole nother level of really interesting work. Would you make welcome our Director of DevOps, Mr. Alex Oskotsky.
Thanks, Bill.
You're welcome.
Yes, Bill mentioned, I'm Alex Oskotsky. I'm the Director of DevOps at Amplify. I've been at the company for about 8 years, and I want to talk about how we've been using AI in our DevOps team. Specifically, the thing we did was we used a service called AWS Forecast to do predictive scaling for DynamodB. So this is like a little bit technical. I'll try to go over how we use DynamodB and what our problem was with it, and how we used AI to help to fix the problem. But I'm looking forward to any questions you have about this also. So first, some context. We use DynamodB for a lot of our databases. At Amplify, we have a lot of microservices, like a lot of really tiny services. Many of these services use DynamodB as their backend. So in total, we have about 100 of these tables in production. So that's a lot of tables. For each of these tables in Amazon, you have 2 options how you can provision them. You can either do pay per request or do provision capacity. With pay per request, basically, it's very expensive. Like if you get a lot of requests coming in, that gets very expensive. So we want to lean towards provisioning capacity for all these tables. Our problem is that our usage is very spiky. Like you can see here on a graph here. Amplify is an education company that's used in schools. So our usage pattern basically depends on when school's in session. At night and on weekends, no kids are using our products. So we're basically getting 0 usage. You can see this graph basically going to 0 at night. But during the day, we need to very quickly scale up to a huge number, as all the schools basically just log in at the same time. So we want to be able to set a provision capacity number for these tables that takes that all into account without wasting too much money. The obvious answer for that is just use auto-scaling. That's built into DynamodB. This kind of a solved problem. Our issue is that we need to be able to scale up very fast, right? Like you can see on this table, for this one specific day here, we go from 0 to like 10,000 within an hour, right? Amazon will provision you 10,000 units, but it's going to take a few minutes for it to get there. It's not going to instantly go 9 a.m., the bell rings in school, and you have 10,000 units. It's going to take a few minutes. And while that's happening, users are seeing this. They're going to see these throttled errors. If you make a request to DynamodB when there's not enough capacity available yet, DynamodB throws this throttled exception. And you're basically supposed to retry your request until the capacity is there. So this is going to take a few minutes, so it's not terrible. But during that time, our users are either seeing some errors in the worst case, or they're just seeing slow page loads, while our backend keeps cycling, waiting for this capacity to be there for a few minutes. Our problem is that this is going to happen every single morning. Every single morning, our tables are going from 0, which is 10,000, right? So every single morning, the first few unfortunate teachers in that morning are going to be seeing this bad experience. We'd really like to just solve this, once and for all. Basically, pre-provision our tables at the right amount of capacity for the day, right? So that's actually available in DynamodB. When you set up that auto-scaling, what you can do is you can set a min and max value for your table. So basically, we can force DynamodB to pre-provision enough capacity before the usage is there by just bumping the min to where it needs to go, right? So if we know that at 9 a.m. we need 10,000 units, then maybe at 8 or 7 a.m. we just set them into whatever number, so we guarantee there's going to be that much capacity when the schools start. And you end up with a graph like this. So this is kind of like a scaling schedule, where we have some min values and max values for like one specific table. So basically, in the morning, we bump it up to 2,000, then some more around noon, and then scale it back down at 0, basically just by changing the min value. DynamoDB will then provision an actual capacity based on your usage, somewhere in between these min and max values. So this pretty much solves it. Like, we can do this, and we've been doing this. Our problem goes back to, like, and here's an example of what that looks like. So you can see purple line is how much DynamoDB's provision capacity we have, and the yellow line is the consumed capacity. So you can see we basically forced it to provision an extra 2,000 units before anybody was even in the system, so that it could keep up with our usage as users log in, right? So this pretty much solves it. Our problem is that we have hundreds of tables, right? Like, we need to do this for every single one of those tables. And each of those tables also has global secondary indexes, which basically need to be provisioned separately. So those indexes also need their own schedules. So it's about like 300 different things we need to be setting up, which is just a lot of effort for us. And we need to basically keep those schedules. We need to maintain those schedules, because in the summer months, we have way different usage than during the school months. So we need different schedules. Every school year, we need to basically update 300 of these schedules. So it's a huge pain for developers. They don't want to do this kind of really super boring work, right? And this kind of task is perfect for AI, which is basically what we did. Amazon has a service called AWS Forecast, which is used for making predictions on time series data. So in our case, the time series is our DynamoDB usage per table over time. And basically, the AWS Forecast can just make predictions for some future timestamps. So here's an example of what that looks like for like one table. The yellow line is just how much we use throughout the day, and the green line is the actual forecast. It doesn't need to be perfect, because we're just using the forecast to set the min value for the auto-scaling. We're still going to use regular auto-scaling. We just want to make sure that we scale up ahead of time to the right level, so that auto-scaling can keep up without too many throttle errors. So we just need to basically be in the ballpark. So instead of going from 0 to 10,000, we create a forecast and then scale up to some number we think is appropriate based on the forecast an hour before school starts. And the best part is, because it's all, we can just basically always automate this entire thing. We can generate forecasts and just automatically do this, instead of asking all of our devs to manually be typing in a bunch of configuration everywhere. So that's the goal. And if you do it right, then you can save a lot of money, in addition to all the developer time. In that first table that I showed you before, the team that was managing that table was like super lazy. They just hard-coded 2,000, because they were afraid of those throttle errors, and they didn't want to spend too much time picking the right scaling schedule. So they hard-coded 2,000, and they end up wasting a ton of money, right? But by doing this with regular auto-scaling, you can obviously just have your table be provisioned correctly. You're not wasting any money over provisioning, and you're not wasting like dozens of hours having to maintain these schedules that no one wants to do. So that's what we're trying to get at. So like I mentioned, we use a service called AWS Forecast. In our case, we wanted to automate this entire thing, so we basically just glued it all together with a few lambdas that run on a schedule. The first step you need to do in AWS Forecast is train a model that's going to be doing these forecasts. In the AWS Forecast service, they're called predictors. So our first step is to train a predictor. And to create a predictor, we actually need to feed a data first, right? So in our case, we create a Lambda that collects DynamoDB metrics. So basically, it's querying the AWS API, collecting our usage data over time, right? And we feed that into AWS Forecast. What AWS Forecast expects is just a CSV file of basically the name of your table, the timestamps, and what level it was at. And we basically collect this data for an entire year. So we create this giant CSV file, all of our tables, all the data for them, and we feed that into AWS Forecast using some Lambda functions. This Lambda function runs every hour, actually. So every hour it's collecting more data, putting it into a CSV file, dumping it into an S3 bucket, and feeding that into AWS Forecast. Then we can just train, then once the data is in the bucket, we can then train a model. In our case, that's actually just another Lambda. This Lambda runs maybe once a week and basically retrains the model with the latest data that we have. In our case, it was really important to keep retraining the model because our usage patterns are changing. In the summer, we get very different uses than during the school years, during the school months. So we wanted to retrain the model to use the latest data that we've been collecting every day. So you end up with a couple of Lambdas like this that create the model. Once you have a model, then you want to start creating forecasts from the model. The forecasts are very similar to the input you're giving it. It's basically just another CSV file, the name of the table, the timestamp, in this case in the future, with the value that we're predicting. And then once we have that forecast, we can then use that to set the scaling schedule that we saw before. So that little step function with the min and max values. And we do that with just a few more Lambdas. First, we have a Lambda that runs every few hours that basically requests a new forecast. The forecasts basically come out as CSV files in some bucket. Once the bucket's populated, we can then have another Lambda that takes that data and basically constructs a forecast by calling into the DynamoDB API. In our case, there's actually a service in Amazon called application autoscaling where you set up those min and max values for your table. And that's basically it. It's about like 3 Lambdas. There's a few more Lambdas for monitoring the system and so on. But basically, once you have this set up, it's fully automated, right? We collect the metrics every hour. Every few hours, we're creating new forecasts. And then about once a week, we retrain the model. And basically, we're saving our developers a ton of time. And this is kind of what it looks like. It looks very similar. Basically, this is what it looks like. So you can see like the yellow line here is our consumed capacity, and then blue line is how much we're provisioning. It's very similar to what you would expect from autoscaling. It's basically just matching our capacity. The difference here is that we're guaranteed to scale up in advance. So we're not risking the throttled errors we would see before just by using the default built-in autoscaling, right? We're still using autoscaling, but we're pre-provisioning a little bit in advance to limit the number of throttled errors we're seeing. So it works pretty well. It definitely saves teams a lot of time. So I think it's a good solution. So yeah, I'm looking forward to any questions you guys have about this. And I think I'll hand it off over to Jonathan to talk about SecOps.
All right, thank you very much, Alex. Thank you very much. So, as Bill and Alex mentioned at the top of the hour, I'm Donelly Constance, Director of SecOps here at Amplify. I've been with Amplify for about a decade or so. In that time, I've worn a lot of different hats. I've been QA, I've been SC, I've been DevOps, and now I'm SecOps. So I'm going to talk to you a little bit about what I've been doing in our SecOps org with AI. So 2 things. We've explored vulnerable app code for developer education, and we've also looked at tabletop exercises for junior engineers. So a little bit of background. Amplify is an ed tech company. We believe in education. We have our own internal development conference. So we get the entire company all in one place. This year it was in Brooklyn, about 400, 500 engineers. And the SecOps org decided, hey, let's run our own capture the flag exercise to help engineering better understand app vulnerabilities and how they can fix them. Now, if you don't know what a CTF is, basically, it's a hacking competition where individuals or groups of individuals compete against each other to see who can solve the most security puzzles. And the reward is basically you get a flag for solving a puzzle, you submit that flag for points. That's the basic gist. So let's see if we can get GPT 3.5 to build one. So this is an example prompt that I put into our own chatbot UI. An important part of this is that ChatGPT won't generate vulnerable code for you anymore. I think it did when it first came out. Now they've locked it down pretty good. You can't do that. So you have to go to the OpenAI API instead. So that's what this is using. There you go. So in this case, little prompt, I asked it, I'm working on a workshop, fix vulnerabilities in code. Can you generate an example web app, so on and so forth? It gives you a bunch of code. It'll give you a lot more stuff that we'll talk about in a sec. But you get the idea. All right, so we built the entire thing with GPT 3.5. We generated a simple single-file Python app. We got a nice little app.py. It uses our preferred stack at Amplify, so everything is the same. Engineers understand everything that's going on there already. It also made us a Docker file and a Docker Compose to make local development easy for those engineers. It also gave us a little README with different suggested challenges for people to complete during our capture the flag. Here's an example of some of the vulnerable code it generated. So this is the /register endpoint of our fake service here. It's using Flask. It has 2, probably more, problems. But if you can spot them, great. If not, Well, the first problem here, so we're taking in a post. One of the things we're taking in is user type. So anyone can send a post to this and say that they are admin user type. Not great. The other problem here, we're not really generating any sort of secure ID. We're just base64 encoding it. So it kind of looks interesting, but it makes it really easy to enumerate all user IDs, which is also not great. But yeah, so we've got a few different things for developers to find here. All right, so now we have a CTF. And that's what we did. So at our internal developer conference, we ran a workshop with our engineers where they competed in the CTF. The engineers had a lot of fun playing with the app locally. Everyone was able to clone down the repo, run Docker build. It took 5 seconds. Great. It sparked a lot of new interest in our application security program, and it's led to the creation of our own cross-discipline bug bounty guild. So we have QAs, we have DevOps, we have SecOps, we have software engineers, all working together to find bugs in our own apps, and also they're looking industry-wide and trying to participate in other bug bounties. And best of all, we built it all in a day with ChatGPT. Now my second part, tabletop exercises. So people might not be familiar with that term, tabletop exercises. Basically, it's a simulated exercise where you have one or more facilitators present a scenario and responders work through it. And it's not just a DevSecOps thing, it's not really a CS thing, it's any kind of industry. This is disaster management, emergency response, police departments, fire departments. A fire department might have some sort of tabletop exercise where they say, okay, we have a high-rise fire. What do we do differently if it's a 10-story building versus a 50-story building? What kind of trucks do we need? What kind of personnel? You get the idea. So why are tabletops great? For DevSecOps, it helps you introduce engineers to incident response. They get used to the idea of making an incident, understanding how to go through the different steps, when to bring in different people, all that stuff. It helps build their investigation skills. So they're going to work with a facilitator. They're going to say stuff like, I look at the logs in system X. They start to understand how things work. They're going to also understand the basics of your services and your cloud provider and how everything works together. It also gives them a nice little confidence boost for the first time they go on call. It's always great to have done a few tabletops before you get woken up on Saturday at 2 a.m. But why aren't you doing them every week? They take a lot of time. You need a senior engineer who really understands your stack. They need to do all the prep work of building out a scenario. They actually have to do that multiple times. You probably want a good cadre of 10 or 20 different scenarios that you can run over and over and over. You also need to spend a lot of time coordinating, getting folks together. Your senior engineers, they're probably very busy. Maybe they're away at a conference. Anyway, they also might have to work with multiple teams getting together all at the same time. And so that makes that really hard to scale out. It's really hard to have every junior engineer in your org be in that hot seat and have that experience. So, ultimately, tabletops are an adventure game. And that's great because GPT knows text-based adventure games. So let's talk a little bit about prompt engineering. So I'm going to have 2 sections, basic premise and stack information. So here's the first little bit in our little fork of ChatGPT. The first section here, I'm just setting up the premise. We're conducting a tabletop exercise. I'm saying it's going to be a security incident. I'm saying that ChatGPT is going to be the admin of the exercise, and I'm going to be the incident commander from the security team. So I'm sort of leaning it into the idea that it's going to be a security issue. You can write whatever you want. You can say, I'm the tech lead, I'm the product owner, I'm the QA, and it'll sort of generate an appropriate exercise for you. And then in the next section, I'm saying, give me an initial prompt to start the exercise. I'm also going to do some little bit of guardrails here. So I'm saying that it's an adventure game, and to generate 3 to 5 options for me to pick. They could be inappropriate options. They could be options that make the situation worse. We want to have some fun. And then the next section here, after I select an option, tell me what happens. Was I successful? Give me some realistic output from the servers, from the commands that I had it run. Do whatever. And then in the next section here, just a little bit of information about your stack. So as Bill and Alex both mentioned, we use AWS as our cloud provider. I've listed off some of the different major services from AWS that we use, just to sort of prime the pump for ChatGPT. I said we've used Datadog, and I've also given it a very brief overview of, yes, we have a central gateway service that uses Nginx and console to forward requests. So that's the basic gist. And then that's the whole thing all together. So let's see what that looks like. Now the fun part of every presentation, where we find out if the Wi-Fi works.
Looks good.
So I've preambled this, I've put in my prompt. This is what I got back from our bot. Let's full screen that again. All right, so you receive an alert from your security monitoring system indicating there's been a suspicious spike in outbound network traffic for one of your EC2 instances. This instance is running a backend service that handles sensitive customer data, so that means PII, and your goal is to investigate and mitigate any potential security incident. And it's given us a few different options here. We can review the logs for the EC2 instance, we can look at the network traffic logs, we can shut everything off, we can punt it to AWS support, and apparently we can go back to sleep. Bill would not be happy if I picked 5.
That's not good.
So we're going to go with a different one. We're going to look at the logs for the EC2 instance. All right, and so yes, it's acknowledged we've picked that option. It's told us the logs look suspicious. There's a lot of traffic to an outbound IP address that we don't recognize. That also says that there's unusual patterns in those logs. So now it's giving me some new options. And okay, we can investigate the IP address. We can analyze the inbound traffic to these 2 instances. We can bring in the proper incident response team. We say that this might be a security breach. Let's get more eyes on it. We can take a snapshot, or we can just immediately update everything, I guess. Some of the options are inappropriate. That's okay. So I'm going to say, hey, let's get the incident response team involved. And now, I think this will be the last one we do. Sometimes these can be solved in like 3 options, 5 options. Sometimes you might be here for like an hour because ChatGPT will just make stuff up. It'll be like, oh yes, you blocked that IP, but now the North Koreans are attacking. Okay, whatever. So let's just say, okay, we told the incident response team we might be hacked. Now they want us to give them the logs. They want us to coordinate with the AWS support team. Yeah, let's tell the lawyers that there's a problem. Okay, so we've told the lawyers there's a problem, so on and so forth. Now we have some new options. But you get the idea. And this is something people can copy and paste that prompt, update it for their stack. You can be doing this in the break. All right, and then as the backup that we always have, this was the saved options from before in case we didn't have Wi-Fi, but we did, fortunately. But anyway, so as I said, that version had some guardrails. It was generating options for us. That's really great if maybe you're an intern and you don't really know what options are. But you can also just sub in this paragraph, remove the bit about generating the options, and then you can have it be much more free-form and free-flowing. That might be a little bit more appropriate for an associate engineer. But anyway, so recap. In my opinion, not as useful for a senior engineer or someone who's already really well-versed in incident management. I don't think you're going to learn anything too new there. Not really a replacement for having a proper incident management system. You want to be able to document your incidents. You want to be able to run good retros. You want to be able to share out the results of those retros with your engineers. However, probably pretty good as an onboarding process. If you're bringing in new engineers who may not be familiar with AWS at all, or may not be available, may not be knowledgeable of your stack, this might be a really great way to introduce them to those things. Or it might also be a really good option for refresher training for your junior engineers. But that is that. And now, for some closing thoughts, Bill Donelly.
Thanks, John. Jonathan, thank you. Thank you. The things that Jonathan just showed, the tabletop exercises, are so powerful. We showed an information security example, but you can use them for any process. Our thinking back at our team is, if you haven't tabletopped it, you're not going to know if it works or not when you actually need to use it. So you really are important. They cost money. We pay consultants to help develop and facilitate those. So could we do it without AI? We could, and we have. But does this make it so much more efficient and so much more usable, and we can do it so frequently without constraints on budget of paying outside consultants? Absolutely. So as I mentioned in the beginning, we're trying to make AI, we're an agile shop. We're trying to make incremental improvements. We're not trying to blow up everything. AI is going to solve everything. incremental improvements in our workflow to do things better and more efficiently. And Jonathan's example was great. Capture the flag. Could someone write that code in that exercise? Yes, they could, and yes, they have in our company. However, this was more efficient, and it was written, I think Jonathan pointed out, and I said in the beginning, play safe. We've found cases where ChatGPT or GPT 3.5 will write code and give it to you very authoritatively, like this is what you need, your bash script, whatever it is, your Python script, and it's absolutely incorrect and it will not work. So you have to be careful not to go into production with things that come out of there. It's treated more like maybe a suggestion that needs to be tested and verified with human beings before it actually goes live. Alex's example, can you scale DynamoDB databases without AWS forecast? Yes, you can. Yes, we have. As Alex mentioned, it's labor intensive, and our time of our software engineers and our DevOps people is way better spent in other areas. So the automation that Alex demonstrated to scale those databases correctly, in his example, we were saving, $100 on that one?
1,000.
1,000, and we have hundreds of those databases in our environment, and you may as well. If you don't use AWS as your backend, other cloud service providers are providing those type of tools to do the same thing that AWS Forecast is doing in an AWS backend. And the examples that I showed, we do need to understand how we support our engineers and how we can do it better. That data is buried in Slack messages that could really never be processed manually. The tool we found to do that is going to be very helpful for us. And data that's in a structured database, a SAS database, these companies, Zapier, QuickBase, Airtable, are all starting to provide AI tools to analyze the data that you have and do predictive AI on that data. So we want it to be practical. You can skip a little bit, John. Thanks. These are the things that we covered. I hope you can use some of them. I hope that we in Astro Tools team can be like the women from Oregon that handed my wife and I the menu and solved a lot of problems for us. It made it easier for us to eat lunch. I hope we can do that for you, and maybe you can use some of these AI tools when you return from the conference. There's other piece of slide here. If you need to reach us, please feel free to email us. We consider ourselves a best practices group. We are really honored to be here sharing with our colleagues in DevOps Barcelona. So if we can be helpful, let us know. We'll be back in New York next week. And the presentation, if John rolls a little bit forward, the links to a lot of the things that we covered are here. And some articles that might be useful to you are on the next page. So if you'd like to have those links, let us know. We'll send you the presentation as well. And if I could close by thanking my great team that traveled with us here and my great co-presenters. And thank you, Ricard, and the DevOps Barcelona team for putting this great conference together for all of us. And thank you for being a great audience.
Yeah, and we still have some time for questions. There are quite a bunch of them. I'll try to group them because otherwise it will be... Let's talk first about, costs. Of course, AWS is pricey.
Yeah.
People are asking, okay, more or less, how much did it cost to, set up all this forecast thingy with all the lambdas, more or less? If you can disclose some numbers, because obviously there are some bits that... No, you can...
Oh, all right.
No worries.
With AWS Forecast, you pay in two ways. You pay per hour for training the predictor. So in our case, each time we train the predictor, it took a couple hours, and you basically pay... I forgot the price, but you pay a few cents per hour that you spend training the predictor. So you can calculate that out. In our case, if you train the predictor once a week, it takes a few hours. Maybe it ends up being a couple of $100 a month maximum. And then you're paying per forecasted data point. So that depends on how many tables you have. So in our case, we have a few hundred tables. We were creating forecasts for 24 hours in advance. We were creating 24 data points per table because we wanted to know the usage of each of our tables each hour for the upcoming day. So that ended up also being a few hundred dollars. It basically depends on how often you want to regenerate the forecast and for how many data points you're doing it for. But I think overall, you can definitely save a lot. By doing this, you can definitely save a lot of money overall, because you're cutting a lot of DynamoDB prices, a lot of costs, for minimal price cost on the forecasting side.
Right. There are a number of questions around capacity planning, generally speaking, let's say. Do you have anything to deal with one-off events? Maybe in your line of work it doesn't happen that much, but let's say, how would you combine both the capacity plus one-off events.
Yeah, I mean, in our case, the forecast is used to control the min level. So we're still setting a max level. So basically what you can do is just set a very high max. Like basically say you're okay with it scaling up to a huge number, and you're just using the forecast to control the min. So if some sort of one-off event happens, you probably will see throttle errors, but eventually it will scale up sort of a max you wanted.
Sorry.
Yeah, so do it that way.
Okay. And yeah, hold on, there was something. Yeah, some people are asking like, okay, say you want to prepare for a Black Friday, right? But you don't have a lot of data to train. Like, what could you suggest to those people in order to have at least some model to, let's say, have some capacity planning?
Yeah, I mean, at that point, you basically have to fall back to a hard-coded schedule. In the future, what we probably could do is give an option for users to input some known schedules that they want to make sure are there, in addition to whatever's being forecasted. The other alternative is maybe just have a huge amount of data. If you have like maybe 5 years of Black Friday data, the model might be able to figure it out, but you'd have to try it in your specific case.
And for a continuous, let's say, continuous environment like yours, like continuous in the sense of like, it's not a one-off thing, it's like constant every week, more or less. And what's the, let's say, minimum time series that you would consider, let's say, intelligent enough, or good enough to train a model? Like 3 months, 6 months, 1 year? Well, I guess it depends on the business, yeah, right? But
yeah, it really depends. In AWS Forecast, there's a monitoring tool, so they basically will tell you how close the forecast is created versus the actual. So basically what's happening is every hour we're giving it more data, and on the AWS Forecast side, it's able to compare what actually ended up happening with the forecast it generated previously. So there's actually a metric that is generating that's basically telling you how accurate the forecasts were over time. So basically you'd have to play with it. You'd have to play with how much data you're feeding it, how you're structuring the data, and basically watch the metric to see how accurate your forecasts are becoming, if more accurate or less accurate over time.
And some other people are asking about, like, say, the operations alongside all this work, yeah? So imagine the DynamoDB provisioning fails. Do you still rely on the other auto-scaling? Because then you can enter a cycle where, you are crashing, but Dynamo is not scaling, so it cannot cope, all this sort of thing.
I mean, ultimately, you just fall back to the regular auto-scaling. Like, the thing you're trying to solve is those few minutes of throttled errors. So in the worst case, it kind of gracefully falls back to what we had before, where like for 5 or 10 minutes, users are seeing slow responses, and eventually it'll scale up. So it's not going to cause like a full incident where like teachers are still going to be use the app, but it's going to be a little bit suboptimal. So in that case, we would hopefully have good monitoring to notice that the forecast was not great that day and adjust it somehow. So the next day, it would make a better forecast and wouldn't end up falling back into those throttled errors.
All right, and I think this covers more or less most of the topics. I guess you'll be around, and of course, you offered yourself to answer more questions online. So thank you very much, everyone. Thanks for coming over here. We're glad. So thank you very much.
Thank you.
There's lots of.
All right.